Welcome to this presentation of the Augusta Reader by Slim CD. The Augusta Reader is a device made by ID Tech that Slim CD supports, and we're going to go over how that support works. Here's a little information about the Slim CD company. I've shown that in a lot of slides, so we're going to skip past that. We have the ID Tech Augusta. It is both it is an MSR card swipe replacement device. So I'm going to pause for a minute and bring up my video camera and show you. Here is a traditional MSR card swipe device that allows you to swipe. This works in keyboard emulation, where if you plug this in and you can swipe the card and it'll dump information into the keyboard card buffer. This is an Augusta. And as the slide shows behind me, there is a card swipe slot here and there's an insert slot here. The amazing thing about this product is it also works in keyboard emulation mode. So inserting a card or swiping a card provides information in the keyboard card buffer the same way that a regular traditional card swipe device does. So let's go back to our slideshows here. It is in keyboard emulation. It's 2 readers in one. It supports swiped EMV chip cards. You can do fallback, which means if you can't read the card properly, then you swipe and you get a lot of the same protections as you would with an EMV chip. And talk to your merchant service provider about the benefits of fallback. It supports credit and signature debit, so it will support debit cards, but only those with a Visa and MasterCard logo, and they're processed on the credit card rails without a PIN. So it can also do gift cards. So, traditionally in a Slim CD web service, when you're using a mag swipe device, you call our Direct Connect APIs or use our hosted payment pages, etc., and you place data in the track data field for regular card swipes. Well, with this particular device, you can also put information in the track data field that we will recognize as coming from an Augusta, and we will populate the EMV tags for you. There's a separate field for EMV tags in our APIs, but we'll recognize the Augusta. That way you can simply drop it in to development that's already been integrated with Slim CD without having to move things around. But you can put it in track data, you can put it in EMV tags. Either way, we can recognize it because the Augusta is so uniquely positioned and signatured. So it's a wonderful device that makes amazing sense to use. There are no drivers to install. It is plug and play. It works on websites. It works in pause systems. Just an amazing device, and we're going to show that to you live action here in a minute. So our web services take name value pairs, JSON or XML, and we've also got libraries that wrap the regular posts to our web serve calls, and I've got lots of videos on those, so please check those out. But in this particular case, the one property or the one field you're filling in is simply the track data field, just like you would with a regular track data. So you can capture track data or EMV tags from the keyboard buffer, just like with a mag stripe, and you just put it in there and we will handle it from there. You can put it in the EMV tags field, but you don't have to. There's no EMV certifications required, and the Augusta does all the encryption in the hardware so that when the data passes through you, you don't have the decryption keys, so you've minimized your PCI scope on all those swipe transactions. If you use an Augusta card reader with either an ID Tech keypad to key in card numbers, or which also goes in the track data field for typed in input, or you can actually use a hosted payment page that displays, so you can type in information in a hosted payment page. You can completely take your point of sale system out of PCI or even your cloud-based system, because it all works through the keyboard card buffer. This device is the most universal and easiest plug-in way to go for EMV, up and running in no time flat. So I've got some sample code I'm going to show you that proves just how easy it is to use this Augusta card reader, and I'm going to fire up the sample code here. Now this sample happens to be in .NET, but this would work with any language because it is so simple. So here is just a simple .NET application, and I'm starting this up. And we're going to fire up the application. So, where'd it go? Here it is over on the other screen. So here's the application. It is mimicking a point of sale system. In this particular case, I've designed it so that you can swipe a card, you can key in a card, or you can insert a card. So let's bring my reader up so we can see this in live action. And if I were to type in a card number on my keyboard, I could process a key transaction by also putting in a card number and an expiration date. In this case, this is all about the Augusta. So I'm going to take a chip card and I'm going to follow the instructions. It says insert it this way. Insert it. It'll beep. And I happen to be showing you the data in this case because I want you to see it come in. It's a little bit longer than track data. Now this particular sample is waiting in the background. It realizes that it's got all the data it needs, so it automatically posts over to the payment gateway. In this case, it posts over XML, and it gets back the standard SlimCD response. Check out our Direct Connect API documentation. The standard SlimCD response, including the token and all the information you need, the name of the card holder. It was able to get that off of the data from the EMV chip card, type of card that it was, the last 4 digits, expiration date, all the information you're allowed to store. Here are some EMV reply tags that in other devices you'd actually have to send this to the device to update the card afterwards, but you don't have to worry about that with the Augusta. That's all taken care of for you because it runs in what's called quick chip technology. So with a quick chip technology, it's very fast, very efficient, and you don't have to make as many round trips to the card, which speeds up checkout processing. So let's take a look at the source code. Then what it does at the end, it transfers over so you can see the receipt. If you want a full SlimCD receipt, here's a full SlimCD receipt with one web service call. And if you just want the EMV tag so you can print your own EMV receipt, there's a web service call you make with that token ticket number that gives you back as either text or XML what you need to put on the receipt. By just grabbing this text block as it comes back from our web service and merging that on your receipt, that's all you have to do. So let's take a look at the code behind for this sample. Now I happen to be using the slimcd.net library just because it's simple to do. So I start a timer and I fill in the credentials for the SlimCD gateway. Again, I'd recommend using API access credentials anytime you see a username. Check that out in the API access credentials video. And you provide the rest of the credentials here. You put the name of your PAWS system or website or cloud-based PAWS and the version number. And here's the transaction, trans type and amount. So really this is the information that matters. Now in this case, in this sample, I'm allowing duplicates because I want to be able to run a lot of cards without duplicate declined errors. So I do a simple test and say if the card number starts with a % or a semicolon, it is unencrypted track data, put it in the track data field. If it starts with 02 and ends in 03, it is encrypted ID tech data, again, put it in the track data field. If it's greater than 6 and it starts with this or this, in that case it is EMV tags. I could put it in the track data field and our payment gateway is smart enough to use it out of the track data field, but alternatively, since I have a separate property for EMV tags, I'm simply going to put it in the EMV tags field, and I do a second check. If it has this prefix or this prefix, it's actually some error reading the card, and I can display those here. I've got a list of those errors built in this little sample program. That way I don't have to make a trip to the gateway. But this little bit of code is all we need, and by the way, if it's greater than 2 and it's not one of these things, it's a keyed card, and so I put it in the card number and expiration month and year. So I've taken care of unencrypted, encrypted, EMV, and keyed transactions with this little block of code. I've set up my payment gateway request. I wipe out the information just so it looks nice, and I simply call process transaction from the library, and I show you the XML results that we get back. I parse out the gate ID and transfer over to the receipt tab to show you the receipt. And we saw all that work. So as you can tell, this is not a lot of code to fully integrate EMV, and really it's just filling in either the EMV tags or the track data with the same stuff you got out of the reader that you would have with a regular keyboard card swipe, and obviously calling the SlimCD payment gateway is pretty simple too, and getting back your responses. So that's a very fast, very efficient way to process EMV transactions. So I've gone over this PAWS interface. I simply put my cursor here and enter the data. Now let's take a look if this was done on a website. We actually can support website functionality, and we're going to do that with this built-in website. This is actually a browser view control that's embedded in an application, but this is just as easily could be a website. This is a payment page that's running on SlimCD's servers, just a little payment page that accepts data. So I'm going to go back to the video, and I'm going to insert the card. Got my cursor in the right field. And again, normally I'd make this a password field or something like that so they don't see all the hex data going by. And here you swipe or type. When I click submit on the web page, that's how quickly I got my response back. Here's all the XML that we just talked about. I've actually parsed it out here, and I show both versions of the receipt. Again, this is just a web page that does all this. Very simple, very easy. Shows you how flexible this device is. It's really powerful. So, the website reply, I just covered all that for you. Our .NET DLLs, I'm not going to go over this a whole lot because we've already seen that, but I will bring that up. Our .NET DLL libraries. This is the code needed to process a transaction, and you're simply filling in the track data. So we will do that real quickly, just for completeness. I don't think I got my cursor in the right place, so let me do that again. I'm going to wipe that out just to make sure we did it right. There we go. So just that quick and easy. And now in this case, I'm not automatically submitting, so I'm just doing a regular post transaction using our DLLs, and again, very quick. Now we've talked a lot about posting over data. This is XML, native XML, and I'm going to do the same thing. Let's skip to the corresponding slide just so we keep everything in sync here. And here's the XML slide. Let's come back to our demo. In our demo program, bring back up the camera. This is XML document, and I'm simply merging in the track data field whatever I get out of the reader. Now I'm posting this with content type application XXX XForm www form URL encoded standard name value pairs, and I get back XML. Let's take the sample code, a look at the sample code behind that, because I think this is important for all developers, whether they're posting XML or JSON, what exactly is going on. Here's the document I showed on the screen, and I'm simply taking what's ever in that text field and putting it inside the XML here, the amount here, and the text here, and I'm URL encoding the whole thing and calling an HTTP post. I show you what I got back, and again I'm parsing out the XML. So it's really not a lot of code to process a transaction with XML. Very simple, very straightforward. XML was quite popular a few years ago. These days JSON is all the rage, and folks like JSON a lot because you don't have to duplicate the tags. It's pretty simple and straightforward. So let's go to our JSON page. There's our XML reply. We covered that. And here's a JSON tab. So I'm going to do just what it says, put my cursor there, and you'll notice in this JSON I'm simply putting whatever I get right in between the quotes in the JSON value. So let's see how that works. Let me click back on the right field. So I'm sending the data to the right application and not the video. Put in the card. The beep is done. I can pull that out. It keeps going. Once it beeps, I can remove it. It's still filling up. And now I'm posting this over with content type of application JSON, and I get back JSON. Same information we saw in the XML, but of course a lot easier to read because you don't have both opening and closing tags. But my gate ID, name on the card, everything we'd like, and again back over the EMV receipt tags that you get for your receipt if you're emailing or printing your own receipts. Let's take a look at the source for that, just to show that what we're saying we're doing matches what we're actually doing. And here, let's go back to the JSON version, and here's the JSON data, and I'm merging in the amount, and I'm merging in with JSON encoding, just in case there's any funny characters, the text right out of that field. Whatever's there, I'm just putting it in here, and I'm calling a JSON post, when the only difference is this is setting the content type as I mentioned, and I'm getting back the response. So anything that can do an HTTP post, not a lot of text, to be up and running with EMV. There's not a simpler solution that we're aware of that's that easy to get up and running. And again, if you use an API access credential, you get rid of all this as well. Just put in the username as the API access credential, actually all of this. So you'd have username, your product and your version, the trans type, the amount, and the track data. Simple as we can make it, and you're processing full EMV. We think that's really a very powerful solution. So again, here's the JSON response we got back. And again, using the gate ID, we're going to look up the data to merge on the receipt, which is one more web service call. Let's take a look at that in the application just so we're comfortable with all the pieces of this. So all we're doing is if you want XML, I'm setting the XML flag, otherwise I'm not, and I'm simply calling the web service with an HTTP post and setting the body of the receipt to whatever comes back from the post. So not very complicated to get the receipt data. Really simple stuff. If you want to use the SlimCity libraries, you can do that as well, but simple HTTP post is pretty simple and straightforward, and most folks that are just using the JSON or the XML directly would just be performing a regular post. So that simply completes the process for getting that information out. Now, of course, SlimCity supports the Augusta inside our own hosted payment pages. Here's an example of a hosted payment page. There's lots of videos on hosted payment pages, but if you enable a swipe field on the form, you simply put the cursor in the swipe field and you can swipe on a regular card swipe or an encrypted card swipe, but now you can also insert on an Augusta right in that swipe form, same way you would with those other things. Great way to integrate with POS systems, so you can do keyed and swiped all on one screen, and it supports it automatically. I encourage you to go to our developers website and learn about our direct API calls, and if you're calling directly, you're calling process transaction, which I've shown you with XML posts or HTTP posts. If you're using our libraries, I've shown you that as well. Very simple and straightforward, and of course there's lots of videos available on our website about a lot of this stuff, and again, all the entry points have all these functions and samples for you already. If you come to our download sample, and I will do this just because I'd like everyone to make sure that they take a look at this sample. Come to our developers downloads page, and under EMV resources, this sample that I've been showing you is available in full sample source code right here, Augusta KB sample. You can download it. It's .NET, but in any language you can cut and paste the formatting of that JSON, or however you want to format that JSON up, and even from your own objects if you want to, with GScript or Newtonsoft's JSON converter, anything you want to do, however you're used to using JSON, it's all available for you. It's very simple stuff to do, and that sample is available in full source code for you right there. So there are the links to the developers website and the download page, and this is by far the simplest, most straightforward way to get up and running on EMV, because there's no drivers, and the computer or Raspberry Pi or whatever it is just thinks this is a keyboard. It works with Macs. It works with anything that you can plug a USB keyboard into, and all you do is an HTTP post to slimcd.com. It can be run from websites. It can be run from POS applications. We've even hooked this up to an on-the-go cable and run it off of a mobile phone. So not a lot you can't do with this Augusta. Very simple and straightforward, and very powerful and effective way to go for integration. We strongly encourage everyone to take a look at the Augusta. If you don't need PIN debit, this is the best, easiest, fastest, most cost-effective entry into EMV. So thank you for your time, and we appreciate you watching the videos from SlimCD.